So let's start with the latest module, where we are going to talk about some examples of how to use precision farming, how to use technology in one of the most important issues we have right now in Europe, which is that farmers need to reduce the amount of pesticide by 50% in the horizon of 2030, according to the Farm to Fork strategy. So we are going to give some examples on how variability in the parcel, how technologies can be used in order to help the farmers. We have two main principles when we talk about variable rate application. We can use proximal sensors, ultrasonic sensors, or LiDAR, or cameras in order to measure and quantify on the go the canopy characteristics, or alternatively, we can use remote sensors like drones or like satellites in order to create our canopy maps, our prescription maps, and then to implement these prescription maps into specific sprayers that we are going to see. The first part is based on the use of proximal sensors. This is an example of when you can use ultrasonic sensors to measure canopy width, canopy height, and canopy density. And in this case, we are able to apply the correct amount of pesticide according to the canopy characteristics. So what we are able to do is to maintain constant the dose per square meter of leaves or the dose per cubic meter of vegetation. It means that in areas where the canopy is higher, the amount of pesticide will be higher than in the zones where the canopy is lower. As a result, after more than 20 years of experience and research in this topic, we have been able to demonstrate that at least 30% of pesticide can be saved. Another example is the optimal sprayer we already developed within the Optima project, an Horizon 2020 project recently finished, where we have been able to develop a sprayer provided with 6 ultrasonic sensors and a sophisticated software and hardware in order to be able to characterize the canopy on the go, not only canopy width, canopy height, but also canopy density. What we have been able to obtain is a reduction depending of the zones and depending of the particular crop stages, but ranging up to 45% of pesticide savings, always aligned with the strategy of the farm to fork strategy. But not only we have been able to reduce the amount of pesticide, we have been able to reduce the risk of contamination, as we have been able to demonstrate that we can reduce drift using these new technologies. The alternative is the use of remote sensors as drones or satellites. Remember the marvelous cycle we have been discussing in the previous modules. From the satellite imagery or from the drone imagery, we have been able to convert it into canopy maps, then into prescription maps, and then to apply these prescription maps. And last but not least, let me give you some data about the operational group Go Fitobit, where we try to use already available technology in order to reduce the amount of pesticide, in this case in grapes. So we use different technologies, different sprayers, different hardwares and different softwares, all together combined with the Dosaviña decision support system in order to define the optimal amount of pesticides according to the canopy characteristics. Just to give an idea of the results, in average, we have been able to obtain 30% of reduction of PPPs, of pesticides, while maintaining the same pest and disease control, using less copper in this case, increasing the efficacy of the process, and increase the quality of the spray application. Then, as a conclusion of this course in precision farming, I would like to tell you that altogether we are here because we need to help farmers in the accomplishment of the European legislation. And the European legislation, through the Farm to Fork strategy, establishes that farmers need to reduce by 50% the amount of pesticides by 2030. It's a combination of technology with good training and education which will help the farmers in accomplishing this important challenge.